So, good morning, everybody. Today, we have the pleasure to have Jennifer Cardenas with us. We are interested in starting new a series of talks. That will be talk 7. So, we will, every time we come with a new episode, we will bring 7 minutes of presentation from expert in a particular area. Today, we are talking about a very interesting topic on helping impaired people with some programming tools. Before that, I just want to quickly present to you what we are. ProBees is a digital education society which talks about equity in education, and it also empowers our future youth by giving back to the society from a professionals of networks. We will be looking into different aspects of promoting education. That could be through scholarships, networks, workshops, courses, trainings, and mentorship programs. Our interest would be to bring workshops like these 7-minute talks, which can give knowledge to the community and helping people. And we want to bridge mostly engineering, sciences, in education to the society. So that's kind of the goal of bringing this complete network, and that helps the society in general. So that's kind of the scope of what we are aiming for. Today, our focus would be on just one talk, which will be done by Jennifer Cardenas. The title of this talk would be Inclusive, Affordable, and Dynamic Programming Tool for Impaired People. So thank you, Jennifer, for joining us. You have about 5 minutes or 7 minutes to talk about this topic and share your knowledge and thoughts about that.
Hello everyone, I am Jennifer and I'm going to present DODO to you, an inclusive, affordable, and dynamic proposal. The objective of this project is to provide a solution to the design challenge of how might we increase a friendly approach to not only increase the coding, learning, and understanding of students with visual impairment, but also motivated. In order to increase the access to inclusive, effective, affordable resources to learn coding for people with visual impairment, and also increase the reach within the labor field for people with visual impairment while growing an appreciation. Now, moving to some key context, understanding and learning the basics of programming helps students to develop an appreciation of how things work. Programming languages have different interfaces that support different ways of expression, so coding can happen on a screen or through objects in the world. Programming can be challenging to learn, and for visually impaired learners, there are numerous additional barriers to the learning process. Many of the solutions that exist today to promote the learning of programming in children are not inclusive, because there is a wide range of possibilities of toys to learn programming that actually have physical elements on it, but however, they rely on highly visual elements to be able to play the dynamics. A key term for this project is gamification, which aims to increase student motivation and engagement by incorporating game design elements like storytelling, problem solving, levels and points. And an important thing right now is that the leading prototype in the visual impaired market are educational devices and software. This is how DODO was defined, a set constructed by different paper models whose goal is to provide an affordable, tactile, interactive way for people with visual impairment to learn computing coding. Each model has its unique paper texture, shape, color, and meaning, and the dynamic consists of a student listening to different activities as missions to then start creating and expressing the solution through the paper models. The purpose is that students with visual impairment can feel the dynamic of how a variable can store a value through the movement of grabbing the value, placing it inside the spot of the variable. And the filter silver learning style model is applied in DODO, which includes the preferable learning style that students with visual impairment prefer, such as learn by trying things out, working on their own, sensory learners, and sequential learners. And now, this is an example of code representation through DODO. On the left side, different models are used to represent the line of code, and they are connected through a yarn to feel the connection between one model and another. And in the current work, the paper model and the real-time object detections were developed for the detection of each paper model. In the same way, the first mission and instant feedback were incorporated to know if what the user is showing in response to the mission is correct or not, with a match between what the user says and what the user shows. In this first video, it is shown how the program recognizes each paper model. In the last video of how DODO looks right now, here you can listen to instructions missions that the program tells the user and he or she has to fulfill by showing the correct model.
Now tell me, which blocky module will you show me?
Variable.
Audio Jungle. Audio Jungle. You did not show the right module. Do you want to try again?
Yes.
Say yes or no.
Yes.
Now tell me, which blocky module will you show me?
Variable.
Audio Jungle. You showed the right module.
For future work, the main areas explored are related to 3D printing incorporation for creating the tangible blocks and the incorporation of small and data blocking models. In the same way, the exploration of how this dynamic can be expanded to other areas not related to programming such as teaching and engineering subjects. Thank you.
Thank you very much, Jennifer, for the wonderful presentation. I hope this will help our future generation and especially impaired people. Bringing this technology to the youth and impaired people will really help the society. It has a direct impact on the society, and I'm very proud that you started this new talk series with your very first presentation. So thank you very much for your time today.